Hello everyone, my name is Arjun from Department of Biotechnology, Ashoka Institute of Technology and Management. I'm here to give a brief introduction and application of UV visible spectroscopy. Spectroscopy is the study of interaction of electromagnetic radiations with matter. Electromagnetic radiations can interact with matter in various ways. Each interaction gives us insights about certain properties of the matter. UV visible spectroscopy deals with the study of the electronic transitions of molecules as they absorb light in the UV, 190 to 400 nanometers, and visible regions, 400 to 800 nanometers, of the electromagnetic spectrum. The absorption of ultraviolet or visible radiation lead to transition among electronic energy levels, hence it is also often called electronic spectroscopy. A light beam is passed through an object and wavelength of the light reaching the detector is measured. The measured wavelength provides important information about chemical structure and number of molecules present in intensity of the measured signal. Thus, both quantitative and qualitative information can be gathered. Information may be obtained as transmittance or absorbance. Types of electronic transitions. The ground state of an organic molecule contains valence electrons in three principal types of molecular orbitals, namely, sigma orbitals, pi orbitals and filled but non-bonding orbitals. Both sigma and pi orbitals are formed from the overlap of two atomic or hybrid orbitals. Each of these molecular orbitals therefore has an antibonding sigma star or pi star orbital associated with it. An orbital containing n electrons does not have an antibonding orbital because it is not formed from two orbitals. In the electronic transitions, promotion of an electron from one of the three ground states, sigma, pi, or n, to one of the two excited states, sigma star or pi star, takes place. Here Beer's-Lambert's law, which is a combination or two laws, as we know, one is Beer's law and another is Lambert's law, one deals with concentration of the absorber, another with the path length. So, it states that the absorption of a solution is directly proportional to the concentration of the absorbing species and the path length. Thus, for a fixed path length, most of the time cuvettes are of a particular size, so they have a fixed path length, say 1 cm. So, for a fixed path length, UV visible spectroscopy can be used to determine the concentration of the absorber in a solution. Spectrophotometer is a kind of spectrometer which measures the transmittance or absorbance of a sample as a function of wavelength, when light of certain intensity and frequency range is passed through the sample. Unlike a spectrometer, which is any instrument that can measure the properties of light over a range of wavelengths, a spectrophotometer measures only the intensity of light as a function of its wavelength. The key components of a spectrophotometer are light source, monochromator, sample area, detector and recorder. Light source. The most suitable sources of light are deuterium lamp, which emits the light in the UV region, 160 to 375 nanometer. Tungsten lamp or tungsten halogen lamp, which emits radiation in the visible and near infrared regions, 350 to 2500 nanometer. Xenon arc lamp, which emits radiation in the range 190 to 800 nanometer. Light-emitting diodes, LED, which emits radiation in the visible range 400 to 800 nanometer. The main function of the monochromator is to disperse the beam of light obtained from the primary source into its component. The principal components of monochromator are an entrance slit, a collimating lens, a dispersing device, a focusing lens, an exit slit. Sample area. Both sample and reference solutions are placed in a transparent cell, known as cuvette. The cuvettes are rectangular in shape, and usually have an internal width of 1 cm. The cells are usually made of glass, plastic as well as silica or quartz. Detector. A detector converts a light signal into an electrical signal. After the beams are passed through the sample under study as well as the reference cell, the intensities of the respective transmitted beams are then compared over the whole wavelength range of the instrument. Generally, two photocells are used as detector in UV spectrometer to record the spectra. One of the photocell receives the beam from sample cell and second detector receives the beam from the reference. In order to detect radiation, Three types of photosensitive devices are present. These are photovoltaic cells or barrier layer cell, phototubes or photoemissive tubes, photomultiplier tubes. This is a schematic of spectrophotometer. These are two here, if you can go through. These are light source. As we have discussed, this could be different light source. There is a filter or monochromator, then there is a reference cell and sample cell. Like I said, there could be of two kinds. One is single beam or double beam spectrophotometers. There is a photodetector amplifier, and then finally, readout in the form of peaks will be shown, that is absorbance. Then here it is a double beam spectrophotometer. You can see, it is the same, but light is here, divided and into two, through a beam splitter, and one goes through, one beam goes to the reference cell, another goes to the sample cell. And then finally, difference amplifier is there and readout is taken like, it is for reference cell, it is 100% transmittance and 0 absorbance is taken. Thanks for watching. Don't forget to like and subscribe for more videos.